Unit 3, Lesson 8, Converting between Standard and Factored Forms. So let's convert from factored form to standard form by expanding or distributing. So we're going to say factored form, 4 times x plus 3 times x plus 5. Here it is. We're going to expand. We're going to do the two brackets first. So we're going to say y equals 4 times, expand using the distributive property. So x times x is x squared. X times 5 is 5x. 3 times x is plus 3x, and then 3 times 5 is 15. Then you would collect like terms. So y equals 4, bracket, x squared. 5x and 3x are my like terms, so plus 8x, and then plus 15. And then we would expand by multiplying the 4 with every term inside the bracket. So y equals 4x squared, and then we have 4 times 8x is 32x, and then 4 times 15 is 60. And then there you'd have your standard form. Okay, we can do the same thing for part B. So you'd say y equals, you leave the negative 1/2 outside, start by expanding the two brackets. So distribute each term. So x times x is x squared, x times 6 is 6x, and then we have minus 2 times x, which is minus 2x, and minus 2 times 6, which is minus 12. And then we distribute the negative 1/2 to every term inside the bracket. But let's first collect like terms here to simplify our work. 6x minus 2x are our like terms. When I subtract them, I get 4x, and then I have minus 12 at the end. And now distributing the negative 1/2, I would have y equals negative 1/2 x squared. Negative half of 4 is negative 2x, and then half of 12 is 6. And negative times negative is positive, so I have positive 6. Okay, now this gives us the idea, or this will bring us to the idea that when we're given something in standard form like this or like this, we would want to factor out one of a common factor, and that common factor would be that 4, making our life a lot easier. So when we have something called a stretch factor, so that stretch factor was a, 4 or a negative 1/2, we always want to try to take it out as a common factor, and then we factor out the simple trinomial that remains. So I'm going to go over some of the basics of common factoring. As I touched on it in the last video, so if you didn't quite understand it, you're going to understand it now. So let's look at some basics of common factoring. What is a common factor? Well, when you talk about factoring, remember factoring is simply this. Factoring is when you write a polynomial as a product of 2 or more polynomials, right? So you want to write this expression, 3x plus 3, as a product, okay, as a product. And we do that by looking at the common factor. So what is the common factor? The question becomes, what is the greatest number or variables that is this factor of each of these terms? Okay, so I'm looking at what is the greatest number. Well, if I look at this term 3x and this term 3, the biggest number that is a factor of each term is 3, right? Because I can divide each term by 3. So when you think of factor, think of division. So I can factor each term by 3, which means when I factor something out, remember you're writing this as a multiplication, right? So 3, so I take out a 3, and it creates some brackets because we're multiplying the 3 by something, and then multiply it by doing this. You divide each term by the common factor. So if I take 3x and I divide it by the common factor, which is 3, 3x divided by 3 is just x, and 3 divided by 3 is positive 1, so plus 1. So what I've done now is I've created this factored form because it's a number multiplied by an expression, okay? And if I want to make sure it's correct, you could expand it again. So 3 times x is 3x, and then 3 times 1 is positive 3. Okay. Now, looking at the next one, 2x and 5. The only factor between 2x and 5 is just 1. But when it's 1, it doesn't really matter. It doesn't change anything. You still have 2x plus 5. So we're going to say it's not possible. X squared and 4x. So not possible. If we look at x squared and 4x, the common factor doesn't have to be a number. It could be a variable. X is in each term. So I'm going to have common factor in x. So this would be x, create your bracket, x squared divided by x is x. 4 times x divided by x is 4. And so I have my factored form, x times x plus 4. It's a product of a monomial x multiplied by an expression x plus 4. Okay. 4x squared plus 10x. So the greatest common factor. So how you do this is write it out like this. Greatest common factor. Well, I can divide a 4x. I can divide 4 and 10. What's the common factor between 4 and 10? Well, it turns out I can have a 2. I can divide 4 by 2, and I can divide 10 by 2 as well. There's also at least one x in each term, so I'll say my common factor is x. So 2 and x is my greatest common factor. So what you have to do is divide each term by 2x, your greatest common factor. Okay. So when I write my factored form, the 2x is separated outside. Create your brackets. 4x squared divided by 2x. So 4 divided by 2 is 2. X squared divided by x is x. So I have 2x in here. And 10x divided by 2x. So 10 divided by 2 is 5. So plus 5. And x divided by x is just 1. Okay. So 2x times 2x plus 5 is my factored form. It's a monomial multiplied by an expression, right? Factors. Factors are what we use to multiply to get our original expression. Okay, looking at this one here, a little bit more complicated, but the idea is still the same. Look at the greatest common factor here. So GCF. Let's write it up here. GCF. Look at the numbers first, 21, 28, and 7. What number do they have in common? What factor do they have in common? Well, like it turns out I can divide each one of these numbers by 7. So 7 would be my GCF. That's 20. And when I say divide by, I mean you have to get an even, you have to have a integer number as a result. So I couldn't say, well, why don't you just divide everything by 28? Because why not? Well, 21 divided by 28 would give me a decimal number. I don't want that. How can I divide each number evenly? Well, the greatest common factor would be 7. 21 divided by 7 is 3. 28 divided by 7 is 4. 7 divided by 7 is 1. Then look at the variables. So c is common in all 3 of them, but the lowest one is this one here. There's a single c. So I have to limit my greatest common factor by just having a single c. Look at the d's. So d cubed, d to the power of 5, and d cubed. So d cubed would be the one I would use. Okay. So while you find your greatest common factor, factor it out. So 7cd cubed. Create your brackets. Inside my brackets, we're going to do the division. 21 divided by 7 is 3. C to the 4th divided by c is c cubed. D cubed divided by d cubed is 1. So I'll leave that as 3c cubed. Minus 28 divided by 7 is minus 4. C squared divided by c is c. And d to the power of 5 divided by d cubed is d squared. And then finally, the last term, 7 divided by 7 is 1, so plus 1. C divided by c is 1. I don't need to write anything else there. D cubed divided by d cubed is 1. I don't have to write anything else there either. So my factored form is this monomial term multiplied by this expression. Okay, let's look at the next one. Common factor. Is there a common factor between 5 and 7? No, and we won't use 1. You could say 1, but we can't. 1 doesn't help us. X, y, and then wz, there's no common variable either, so it's not possible to factor this. So not possible. So we leave it as is. Okay. Now let's convert from standard form to factored form. So do this by looking at this first. 2x squared plus 6x minus 8. You first check, is there a common factor? And usually if there's a number in front of x squared, there might be. So 2, is 2 a common factor between the 2, 6, and 8? It is. So there's a common factor. So do your common factoring first. Okay, so if I factor out a 2, Well, what do I get? Well, 2x squared divided by 2 is x squared. 6x divided by 2 is 3x. And 8 divided by 2 is 4. And it's a minus 8, so I'll say minus 4. So now I have this simple trinomial, and I can use my product sum method. So find two numbers that multiply to negative 4 and then add up to positive 3. Right? So if I write out the factors of 4, I would have 1 and negative 4, and negative 1 and positive 4, negative 2 and positive 2, and you check which of these pairs add up to positive 3. Well, it turns out this one right here, negative 1 and positive 4. So my factored form would be 2, so keep the 2. In brackets, you would have x and minus 1, and then x and plus 4. Okay, I'm going to look at the next one. Fractions. So ask yourself, can I factor out this negative 1 over 3? And it turns out you can. So y equals negative 1 over 3. Create your brackets, x squared. Okay, what's 5 divided by negative 1 over 3? Well, 5 divided by negative 1 over 3, you might want to use a piece of scratch paper. So 5 divided by negative 1 over 3 is the same thing as saying 5 times the reciprocal 3 over 1, negative 3 over 1, and that's going to be negative 15. So minus 15. And don't forget your x. And 56 over 3 divided by 1 over 3. So again, on the side, you could do this. 56 over 3, negative 56 over 3 divided by negative 1 over 3. The same thing as saying negative 56 over 3 times the reciprocal, negative 3 over 1. 3's cancel, and I'm left with negative 56. So minus 56. Oh, sorry, negative times, don't forget the negative. So negative, positive 56, plus 56. I forgot the negative, there's a negative over here. Okay, now, factored form. So can you find two numbers that multiply to give you 56 and add up to negative 15? Well, with a little bit of searching, you'd find the two numbers are negative 8 and negative 7. Negative 8 times negative 7 is positive 56. And when I add negative 8 and negative 7, I get negative 15. So y equals negative 1 over 3, factored form, x minus 8, and then x minus 7. So here's my factored form. I have a number multiplied by expression multiplied by another expression. Last one here, 2x squared, 13x, and 15. Can I divide out 2? No, this makes it difficult. 13 divided by 2 is not a nice number. It's going to give you a decimal, and we don't want that, so we can't factor it any further. And if you tried using the product sum method on this, you'd have difficulties. Okay, so let's look at this next example. Factor fully, then graph the parabola as accurately as you can. So 3x squared minus 6x minus 24. So first thing you want to do is common factor out the 3. Okay, factor out the 3, I'd get 3 times, create your brackets. 3x squared divided by 3 is x squared. 6x divided by 3 is 2, so minus 2x. And negative 24 divided by 3 is minus 8. Product sum. What are two numbers that multiply to give you negative 8 and add up to negative 2? Well, it turns out those numbers are negative 4 and positive 2. So 3 times x minus 4, and then x plus 2. If you're not sure, expand and you can check. Okay, so we have the factored form, we have the standard form. If you recall, the standard form, that's last number c will give us our y-intercept. So our y-intercept as a coordinate is 0, x is 0, the y-intercept, and the y value is negative 24. Our x-intercepts are, from the factored form, remember this value has to be a negative 2 to make that a 0, and this guy has to be positive 4 to make that a 0. So my x-intercepts are 4 and 0, and negative 2 and 0. My axis of symmetry. Okay, so remember it's the average of your x-intercepts. So it's going to be 4 plus negative 2 divided by 2, which is equal to 1. So my axis of symmetry is x equals 1. And so my vertex, if you want the vertex, again, plug in your axis of symmetry into the equation. So if I took the factored form, I could write 1 minus 4 and 1 plus 2. Just replace the x with that 1 from the axis of symmetry. And then evaluate. 1 minus 4 is, so 3 times 1 minus 4 is negative 3. 1 plus 2 is positive 3. 3 times negative 3 times positive 3 is negative 27. So my vertex is going to be at 1 and negative 27. Direction of opening. A value is positive. So A is greater than 0. It's positive. That means it's going to open up. And now I can draw my parabola. So my parabola here will be down here. Negative 24 is my y-intercept. I have a vertex at 1 and negative 27. Sketch doesn't have to be super accurate. And you have an x-intercept here at negative 2 and here at positive 4. So here we just draw our axis symmetry. It's not very accurate. And try to draw a mirrored image point here at 2. And then we can draw the rest of our parabola. There you go. Okay. Now when you're looking at the next one, 2x squared minus 7x, you can common factor this as well. So if I common factor this, is a common factor of x in each term. 2 and 7 doesn't have a common factor. So we'll just leave this as x times 2x minus 7. Okay. Now again, there's no term after the 7x, so the y-intercept is 0. So 0, 0, origin. You can plot that on the grid. My x-intercepts. Well, the idea is you want to make, so if it's a y equals x times 2x minus 7, at the x-intercept, y is 0, right? So it's 0 equals x times 2x minus 7. So what value of x would give you a 0? Well, x equals 0 is one answer. What value of x here would give you a 0? Well, it would be, if I said the whole bracket 2x minus 7 is 0, so if 2x minus 7 equals 0, solve for x. X equals, add 7 to both sides, divide both sides by 2. 7 over 2 is my other 0. Okay, so my x-intercepts are at 0, 0, and 7 over 2 and 0. Okay, if you're more comfortable, you can say 3.5 and 0. 7 over 2 is 3.5. There's no repeating decimal, so that might be okay. My axis of symmetry, well, that would be x equals, add up the zeros, divide by 2, so 3.5 plus 0 over 2, and that's equal to 1.75. And my vertex, well, for my vertex, we have to sub in x equals 1.75. So if I substitute that into my factored form, y equals x, so x is 1.75, times my bracket, 2x minus 7, so 2 times 1.75 minus 7. And when I evaluate that, my answer will be negative 6.125. So my vertex is 1.75 for my x-coordinate, negative 6.125 for my y-coordinate. Direction of opening, A is positive, so it's going to be up, because A is greater than 0. Okay, so now we have the information we need to plot this graph. And here we go, 3.5 and 0. 1.75 and negative 6.125, maybe somewhere around here. And then we just draw a parabola as best we can. Remember, it's a sketch, so it doesn't have to be super accurate. Okay, and there you have it. And that ends this video.